Hello, geometry classes. Today we're going to be talking about trigonometry and more specifically trig ratios. Trig ratios and trigonometry is based off of the fact that similar triangles are proportional. And so what trigonometry does is it says that the ratios between sides of these similar triangles remain the same. So trig is the comparison of the sides of right triangles. And specifically, it's maintaining the ratios of those sides. So when we talked about our special right triangles, the reason that 45, 45, 90 triangle ratios remained the same is because no matter how big or small you make that triangle, the ratio between the sides is going to remain consistent. So today we're going to talk about the ratios in any right triangle. And what we have found is that you can give them special names. So the first name is sine. And this is the ratio of the opposite leg to the angle in the hypotenuse. Now remember, ratios are written as fractions. So when we see sine of A, there's our fraction bar to remind us that we're writing a fraction. And angle A is here. So the sine of this angle is the ratio of the opposite side, which in this case is down here. So A over the hypotenuse, which is C. Then if we looked at B, angle B is down here. Well, the opposite side for angle B is that green one. So we're going to say it's B over C. So, or B to C. So sine of A is A to C. Sine of B is B to C. Now, I have labeled the opposite sides with the color that corresponds to that angle. The adjacent sides are the sides that actually touch the angle. So in this case, our adjacent sides are in opposite colors. So for A, our adjacent side is actually B, and then our hypotenuse stays with C. And then in angle B, our adjacent side is side A, and our hypotenuse is still C. Should have probably done C in a different color, but you get the idea. Now, for tangent. Tangent says that we're going to do the opposite leg to the adjacent leg to the angle. So for A, remember that our opposite side was A, and our adjacent side is B. But for B, that relationship is going to switch. And our adjacent leg is B, and our opposite leg is A. Now, this might seem like really complicated stuff to remember. So we're going to learn a little mnemonic to help us. That mnemonic is so, ka, toa. So means opposite over hypotenuse. Ka, adjacent. Gotta at least get the things right. Adjacent over hypotenuse. And tan, or toa, is opposite over adjacent. Okay, so we're going to look at some examples of how to do this. So the first thing we need to do is draw fraction bars on everything because everything is that ratio. So they're all going to be fractions. Okay? Now, when we're looking at angle A, we're going to do this first column first. Angle A is here, so our opposite side is here. And our hypotenuse stays constant here at 13. And then our adjacent side is 12 for angle A, okay? So A sine is opposite over hypotenuse. Cosine is the adjacent side over the hypotenuse. And for tangent, we get our opposite side over our adjacent side. Okay, so now let's look at C. So I am going to label C with that purple so that the opposite side corresponds to the color of the angle, so you can kind of see it a little bit better. So this side opposite C is 12. This side the hypotenuse, stays 15. So C's adjacent side is 5 with the hypotenuse as 15. And then C's opposite side is 12 and the adjacent side is 5. So ka toa. Remember that. So ka toa. I'm even going to write it out here to the side. You can't write it too many times. Okay. So now for number 2. First, we don't know what our hypotenuse is in this angle or in this triangle. But if you'll remember back to our Pythagorean triples, we have a 9, 12, 15 triangle. Do you see now why those Pythagorean triples were so important? So now I'm going to label first. W is going to be purple. So my opposite side is also going to be purple. And then X is going to be green. And my opposite side is going to be green. So let's go to sine, which is opposite over hypotenuse. Adjacent over hypotenuse. And tangent is opposite over adjacent. Ooh, I didn't change colors. Okay. Now, one thing to notice is that these fractions are not simplified. So you will need to simplify these. Okay, so 4/5 and 3/5. Now let's look at angle X. Angle X, remember, is green. So its opposite side is also green over hypotenuse. Adjacent over hypotenuse. And tangent is opposite over adjacent. Okay. Where did I get 5? I'm losing my mind, y'all, and I'm sure you're like a little wondering where I got that. Sorry. Okay, so now we need to reduce our fractions again. And I forgot to reduce this one. So this is 3/5, 4/5, and 3/4. Now, what you will notice as you look at these two angles in the triangle, and I want to kind of bring your attention to this, is that the sine of W is opposite the sine of X, and the sine of W and the cosine of X are the same, and the sine of X and the cosine of W are the same. So those are the same, and then your tangents are inverses of one another. Okay, we're going to go ahead and do number 3 in the next video.